This presentation explores the extraordinary life of Linus Pauling, a man whose work bridged the seemingly disparate worlds of subatomic particles and international diplomacy. This synthesis of discipline refers to his ability to apply the rigorous logic of science to humanitarian causes, viewing both the chemical bond and world peace as structures that must be carefully built and maintained. Linus Pauling holds a unique place in history as the only individual to ever receive 2 unshared Nobel Prizes. The prizes: 1954, Chemistry, awarded for his fundamental research into the nature of the chemical bond. 1962, Peace, awarded for his relentless campaign against nuclear proliferation and the arms race. Born in Portland, Oregon, in 1901, Pauling was the son of a druggist. Scientific spark. His passion for chemistry was evident by age 11, when he operated a home laboratory with substances like potassium cyanide, chemicals that would be highly restricted or illegal for a child to obtain today. Motivation. He famously stated, "I have always wanted to know as much as possible about the world," a curiosity that drove his lifelong quest for truth. Before Pauling, chemistry was largely a descriptive science of observation. Chemists knew atoms bonded, but not necessarily how. By applying quantum mechanics to chemistry, Pauling provided the mathematical and physical explanation for chemical structures. He introduced transformative ideas such as orbital hybridization and the concept of resonance, which explained how electrons are shared between atoms. In 1939, Pauling published The Nature of the Chemical Bond, which is widely considered one of the most influential scientific texts of the 20th century. This work transformed chemistry from a flatland of two-dimensional formulas into a world of complex 3D structures. It remains one of the most cited works in scientific literature. In 1949, Pauling and his colleagues published a landmark paper identifying sickle cell anemia as a molecular disease. Using electrophoresis, he proved that the disease was caused by a physical defect in a single molecule, hemoglobin, rather than a broader cellular issue. This discovery essentially founded the field of molecular biology. While other scientists struggled with complex calculations, Pauling used a hands-on approach. He folded paper to visualize how a polypeptide chain could twist into a stable structure. He correctly identified the alpha helix, discovering that the chain twists with 3.6 residues per turn, held together by planar, rigid peptide bonds. In the race to discover the structure of DNA, Pauling rushed his research and proposed a 3-strand triple helix model. The model was chemically unstable because he placed hydrogens on the phosphate groups, which would have caused the molecule to fall apart at physiological pH. Pauling viewed this failure as part of the creative process, famously noting that to have good ideas, one must have many ideas, and simply learn which ones to throw away. During the McCarthy era, scientists were strongly advised to not publicize their political views. Pauling did not like to be told how to behave by anyone besides his wife. She often prompted him to think about the moral consequences of his scientific work. In 1957, Pauling organized a massive petition calling for an end to atmospheric nuclear testing. The petition was signed by 11,021 scientists from 49 countries. His activism led to significant government backlash. He was investigated by the FBI, denied a passport for several years, and labeled un-American by critics. This date marked a historic intersection of Pauling's two worlds. On the very day the Partial Nuclear Test Ban Treaty went into effect, the Nobel Committee announced he had won the Peace Prize. He maintained that the only sane policy for the world is that of abolishing war, seeing international law as the necessary evolution of human civilization. In 1960, while hiking at his ranch near Big Sur, Pauling became trapped on a freezing cliff ledge overnight. To stay conscious and avoid freezing, he kept his mind intensely active by reciting the periodic table of elements and mentally telling the unheeding ocean about the nature of the chemical bond. In his later years, Pauling became a controversial champion of orthomolecular medicine, which emphasizes using substances natural to the body, like vitamins, to treat disease. Though the medical establishment largely rejected his claims regarding vitamin C's ability to treat cancer and the common cold, he remained undeterred. His motto remained, "Never put your trust into anything but your own intellect." Pauling's success was built on a specific mental framework. Be skeptical. Always challenge the status quo and think for yourself. Build models. Use physical visualization to solve abstract problems. Bridge disciplines. Apply laws from one field, like physics, to solve problems in another. like biology. Take risks, embrace stochastic guessing, and be willing to be wrong in the pursuit of truth. He had a strong sense of scientific purpose and personal morality. His journey took him to the heights of scientific achievement and moral crusade. He revolutionized chemical structure and the rights of scientists to express their opinions about public matters, particularly if scientific expertise was relevant to the discussion. Linus Pauling was the first, and so far the only, person to receive 2 Nobel Prizes as an individual. He was a remarkable individual and is generally considered one of the 10 most influential U.S. chemists of the 20th century.